So this is question number 13 of the worksheet number 13. We would rank the functions in order of how quickly they grow as x is approaching to infinity. The functions are different here, but we had a similar question in the worksheet, which was question number 10, and those functions were all exponentials. So we had a different approach. But in here we have all kinds of functions. So we know that for each function here, when x is approaching to infinity, the limit of y here will go infinity also. So we would use L'Hopital because whenever we would find a ratio of one of them over the other one, we would get infinity over infinity as x is approaching to infinity. For the first one, we would use x square root of x over x plus e to negative x when x is approaching to infinity. So we would say that this one is infinity over infinity. We would simplify or rewrite it in a way that would be easier to find derivative. For the top, we know that x is actually x to the power 1 and root 2 of x is x to the power 1 over 2. So we have same basis. We would add the powers up. We would get 3 over 2 as the power. And we would keep this one. So we have infinity over infinity, and we can use L'Hopital here. We would get limit of 3 over 2 times x to the power 1 less, which means 3 over 2 minus 1, which is 1 over 2, over derivative of x is 1, derivative of e to negative x is negative e to negative x because of chain rule when x is approaching to infinity. So when x is approaching to infinity, top will be infinity, and the denominator is 1 minus 0 because e to negative infinity is 0. So the answer is infinity. So far, we've found that x square root of x is growing faster than x plus e to negative x. The second one would be limit of x plus e to negative x comparing to 5 root 2 of x when x is approaching to infinity. In this case, we have infinity over infinity as well, so we're going to use L'Hopital. We know that the derivative of numerator is 1 minus e to negative x as we discussed before. And for the denominator, it will be 5 times 1 over 2 x to the power negative 1 over 2 when x is approaching to infinity. So if we rewrite it, we would get 2 over 5 times limit of x power 1 over 2 times 1 minus e negative x, which will be easier to work. So it will be 2 over 5 times infinity. Altogether, we have infinity as the answer of limit. So we would find that x plus e to x is approaching faster than 5 square root of x. Now, we would find 5 square root of x over 10 ln of x to compare them when x is approaching to infinity. Again, in order to use L'Hopital, we would rewrite it in an easier way, which will be simplifying 5 and 10, which is 1 over 2, and we can write it as x power 1 over 2 over ln of x when x is approaching to infinity. We would have 1 over 2, and we're going to take derivative of the limit, and derivative of x power 1 over 2 is 1 over 2 x to the power 1 less, which is negative 1 over 2, over ln of x, and the power and the derivative is 1 over x when x is approaching to infinity. So we would combine 1 over 2, 1 over 2 to 1 over 4, limit of the power here is negative 1 over 2, and the power here is negative 1. So it will be negative 1 over 2 minus negative 1. We would have negative 1 over 2 plus 1, which is 1 over 2. So we would have x to the power 1 over 2 here when x is approaching to infinity. And it means that we're multiplying 1 over 2 and infinity, which means 5 root 2 of x is growing faster than 10 ln of x. So we could order them. The greatest one is x. Let me write numbers here. The fastest one is this one as the first one. After this, we would have x plus e to negative x as the second one. And after that, this one, 5 square root of x as the third one. And the slowest one is 10 ln of x as the fourth one.